Hello my dear students, welcome back to Learn Physics. Today is the last video for this chapter, alternating current. And that I told you in the previous video, we will be doing some more numerical relating to this alternating current. So, the first question is, an electric lamp connected in series with a capacitor and an AC source is glowing with of certain brightness. How does the brightness of the lamp changes on reducing the capacitance and frequency? So an AC bulb is there. It is connected in series with a capacitor and an AC source. So this is a bulb, capacitor is there and AC source is there. How the brightness will be changing? So brightness of the bulb depends on the amount of current which is flowing through it. I is equal to V by Z. That is the formula, right? So Z as capacitance, what will be the Z value for capacitance, or we can say XC. XC equals 1 by omega C, right? That is 1 by 2 pi into nu C. Omega we can write it as 2 pi nu C. Here, how does the brightness of the lamp change on reducing the capacitance? If capacitance is reducing, what will happen? First question is capacitance reduces. At that time, XC will be increasing. XC increasing means Z is increasing. Z increasing, then current will be reduced. So brightness, what will happen to the brightness then? Brightness will be reduced. Clear? So the next one. If the frequency is, while we are reducing the frequency, the same way, if nu is decreasing, tell me, XC will be increasing, Z will be increasing, then I will be reducing. So the brightness will be reduced. In both the cases, brightness will be reduced. Why? Because it is coming at the denominator. Clear? The next question. A resistor of 100 ohm and a capacitor of 100 by pi microfarad are connected in series to a 220 volt 50 hertz AC supply. Calculate the current. Calculate the RMS voltage across the resistor and capacitor. So here in the question it is given like resistance of 100 ohm. Therefore R equals 100 ohm and capacitor is equal to 100 by pi microfarad. And a power supply of voltage is given as 220 volt and frequency is 50 hertz. We need to find out the current in the circuit. How we can find out the current? I equals, what is the formula for finding out the current in the circuit? I equals V by R. So we need to find out, or since it is an RC circuit, we can write it as V by Z. How we can find out Z? Z equals root of R square plus XL minus XC the whole square. Since L is not here, we can write it as root of R square plus XC square. First, we need to find out XC. XC equals 1 by omega C, that is 2 pi nu into C. What is nu? 50. 1 by 2 pi into 50 into capacitor is 100 by pi microfarad. 100 by pi microfarad. So here I can write it as 1 by 100. Pi and pi will get cancelled. 100 into 100 into 10 to the power minus 6. Okay. So here we will get 100 into 100 into microfarad. So 10 to the power minus 4. Here we will get it as 10 to the power plus 4 minus 6 minus 2. So 1 by 10 to the power minus 2 is 10 square 100 ohm. This is 100 ohm XC. Now we can write down Z as Z equals root of 100 square plus 100 square. So root 200 or 100 root 2 ohm, that is Z. Now we can find out I equals Vs 220 divided by 100 root 2. 1 will get cancelled, 11 by 5 root 2. This will be, this much of ampere of current will be developed over there. So, and one more question is there, right? What will be the voltage across the resistor? Next, we should find out the calculate the RMS voltage. How we can find out the RMS voltage? This is the RMS current which we got. So, V will be equal to I into R. What will be the R value here? So I'll write down here I equals V by, voltage only we need to find out, right? RMS voltage. So I RMS into R, resistance. What is the resistance? In the case of, for resistor, this will be the voltage. Voltage across the resistor. I RMS into R. Okay, I RMS how much we got? 22 by 10 root 2. This was the answer for which we got it as ampere. Resistance is 100. Okay, this is the voltage across the resistor. The same way voltage across the capacitor we can find out 22 by 10 root 2 into capacitor value also we got it as 100. Now while we are adding these two, we will get it as total voltage will be VR plus VC, that is equal to 2 times 22 by 10 root 2 into 100. So 44 divided 4.1010, 44 into 0.707 into 10. So when we are substituting this one, see 7 means 44 into 7, you will get it as 30. So nearly equal to 308. Like that I am writing down here. Okay. So, but we applied a voltage of how much? 220 volt. Then how we will be getting 308 volt? It's wrong we will think, right? But it is actually not the case. What will be the reason behind this paradox? See, we are applying a 220 volt and but here we are getting it as 308 volt. Is it possible? No, because here in the case of capacitor, capacitor is having a phase difference of pi by 2. Pi by 2 phase difference is there from the resistance, because resistance value will be actually balancing with the or coinciding with the current. How much of a voltage we will be applying, the same current value will be without any phase difference we will get. But in the case of capacitor, it's not like that. It is having a phase difference of pi by 2. Since we are applying that this phase difference, we should find out the voltage as root of VR square plus VC square. In this method, you should find out the voltage instead of going in this method. Okay, so here this is the paradox which we are obtaining. That one we are just showing it over here. Clear, children? So when we are doing in such a manner, you will get the correct answer. So instead of going for this one, so 2 times. Again we will be getting the same way. You can do the everything. 2 times this root 2 into 22 by 10 root 2 into 100. So here you will get it as 220. Exactly 220 volt you will be getting. Clear? Next question is, find the value of the phase difference between the current and voltage in the series LCR circuit shown below. Which one leads in phase, current or voltage? That one we should find out. Okay, so for that the diagram is given like, it's an inductor, a capacitor, a resistor, LCR circuit and an AC source which is given as V equals V0 sine 1000 t plus pi, and inductor is given as 100 millihenry and capacitor is given as 2 microfarad, resistance is 400 ohm. So this is an LCR circuit. Find the value of phase difference between the current and voltage in the series LCR circuit. What will be the phase difference? How we can find out the phase difference? See, from the impedance triangle, we got one formula for that phase difference. Tan phi will be equal to XL minus XC divided by R. We don't have XL and XC value, right? So how we can find out? XL will be equal to, see, just now we told omega into L, that is 2 pi nu into L, or no need to write down 2 pi nu because sin omega t plus phi, omega it's directly given over here, 100 millihenry 10 to the power minus 3 into 1000. So here we will be getting it as 10 to the power 5 into 10 to the power minus 3, so 10 square. Oh, same way XC. XC equals 1 by omega C. 1 by 1000 into 2 microfarad. 2 into 10 to the power minus 6. So here it is 0.5 into 10 to the power 3. So it is 500 ohm. This is XC. Now we can substitute over here tan phi equals XL is 100 minus 500 divided by, what is the value of resistance? 400. So minus 400 divided by 400. That is equal to minus 1. So what will be the value of phi? Phi will be having a phase difference of pi by 4. Minus pi by 4 will be the phase difference. So it is lagging behind. So here it is getting a phase difference of minus pi by 4. So it will be lagging by a factor pi by 4. Clear? Next question is, an inductor L of reactance XL is connected in series with a bulb B to an AC source as shown. Explain briefly how the brightness of the bulb changes when the number of turns of the inductor is reduced, an iron rod is inserted in the inductor, and a capacitor of reactance XC equals XL is included in the circuit. So the diagram is given like this. Inductor and a bulb is given here, and AC sources given. Okay, this is inductor, this is bulb, this is AC source. What should we find out? Explain briefly how does the brightness of the bulb change when the number of turns of the inductor is reduced. If the number of turns is reducing, if first one, number of turns is reducing. When the number of turns is reducing, length of the inductor is reducing. As the number of turns decreases, resistance will be decreasing. Resistance of the circuit will be decreasing. If resistance is decreasing, what will happen to the current in the circuit? Current will be I is equal to V by R. Okay, so the resistance is, current will be increasing. If current increases, what will happen to the brightness? Brightness will increase. Okay, the next one, if we are introducing an iron rod inside that, right, an iron rod is inserted in this inductor, what will happen? So if iron rod is introducing, while introducing iron rod, if iron rod is introducing in that, what will happen? Inductance will be increasing. Inductance, if it is increasing, how it depends on Z value? Z equals XL. What will happen to XL? XL equals omega into L. Omega L increasing. That means resistance is increasing. If resistance is increasing, what will happen to the current? Current will decrease. Right? If current is decreasing, brightness also will be decreasing. Brightness decreases. So if an iron rod is introducing in between that, this brightness will decrease. The reason is the inductance will be increasing while we are because iron is a very good conductor of it's having good magnetic power. Okay, so it is inductance will be increasing, therefore XL will increase. XL increasing, that means resistance is increasing, therefore I will be decreasing. Next question, capacitor of reactance XC equals XL is included in the circuit. So when we are including a circuit capacitor also here inside that, what will happen? If XC equals XL, how the impedance will affect? Root of R square square plus xc minus xl the whole square. This will be same. Therefore, that one will get cancelled. The amount of resistances, it will be depending only on the resistance. So, here it will be increasing. Current will be increasing. Because the impedance is decreasing, therefore current will increase, then brightness also will increase. Clear? Next, another question. Draw the graphs showing variation of inductive reactance and capacitative reactance with the frequency of the applied source. It's a good question. So, inductive reactance and capacitance with the how we will be can represent using a graph. The graph x-axis and y-axis should be frequency and reactance, capacitative reactance. So, XL equals omega into L. Omega into L is 2 pi nu L. How XC is varying with the frequency is directly proportional. XC directly proportional to nu if L is remaining constant. Frequency varying, according to that XC value will be varying. So XC and nu, how it will be relating? It will be directly proportional. Same way can you tell about XL? What will happen? Sorry, this is for XL. Not XC, XL. XC will be 1 by omega C. 1 by omega C is as frequency increases, XC will be decreasing. So, it is inversely proportional. Inversely proportional means decreasing. XC and C will be inversely proportional. It is inversely proportional, like this we will get. Okay, clear children? So these are some of the questions which we discussed today, and many more questions are available, and you can just go through that. And so with this we are winding up this chapter, and next class we will be starting a new lesson. Okay, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.